Okay, uh, for today's class, we are going to, um, I think, take some examples for chapter 3 for the axial elongation. I think we can start with this problem here. So probably just maybe 2 sets of examples that we can try to work on for today's class. So for the first question, the first problem, we have a steel pot. Okay? We have a steel pot, and the steel pot surrounds a solid. So if you see the picture, number 1 is the pipe. Number 2 is the rod, the aluminum rod. Okay, so you can check first. You can try. The question is, if the pipe from the both ends, given the pressure, the compressive force of 200 kilonewton, we need to determine how the pipe become shortened, determine the shortening of this compression member, and then also normal stress. Okay? Normal stress at the rod and also at the pipe. So when we push this two from both ends, it will give force to the rod, the inside here, number 2, and also give force to this number 1, the pipe. Please check on this problem. Let me give you a 5 to 7 minutes to try. And to give you more clear dissection area, you can see the picture on the right. So you will see that the outside diameter, the pipe, is 50, or the radius is 50 millimeter. The inside of the pipe is 40, and the radius for the rod, the aluminum rod, is 36 millimeters. So that is for, I believe the cross section is for the area, and that will be important to for the stress, right? So first of all, you can try from maybe finding the area first, or you could start from the free body diagram as usual. That is thing pretty much clear. Okay, so perhaps we start with the free body diagram if you want. So let's say maybe from here we cut open that part, and then let me write here. This is the rod, the pipe, okay, and we have P from here, okay. Since we know that this will be going to compressive and the end result will be shortening, I think we could imagine that the force maybe just take that way, okay. Well, this is, I think, as long as you understand the logic, okay. For me, I will just making to the left like this. But perhaps you want to make the F1 and F2 going to the right. That's also okay. As long as you mention that at the end of your calculations, that the direction means compression. I think that's still okay. I would like just to make it going to the left, just to make sure that the end result is aligning with the end result, which is a shortening. So the member will be shortened. Okay, now from here, we get that F1 plus F2 plus P is equal 0. This is from just a normal free body diagram. That F1 plus F2 is negative P. Okay. And then, because they are in the same design, which means the length and the force that is applied to is the same force. So we could simply say that the strain is the same for all member. Which means we can take the strain, remember we can take the formula from the modulus elastic. Okay. So we can take this into taking stress is strain multiply with E. Or we can take the stress into the F over A, right? Or we could simply write that this is F equal strain E and the cross sections. So we could develop for each forces, F1 and F2, both are with each conditions. So each modulus elastic, right? Because they have different modulus elastic, the steel and the aluminum, and different cross-sectional area, right? Okay. And F2 is okay. So by doing this, and we know that we have F1 plus F2 equal negative P. We could add these two, and then we can solve for the strain. Okay. So take this, add both of them. And then we can find the strain, because the strain for both 1 and 2, they are the same strain, which means they are the same displacement will happen, okay, the same displacement. And then this will be negative P over okay. Perhaps if you don't want the calculation to be messy, maybe let's find the area first in different sections. So A1 is the rod, right? Oh no, the pipe. The pipe is pi. The radius is 50 squared minus 40 squared. Let's check. This is going to be 27.43 millimeters squared. And A2 is 36 squared. This is 4071.504. Okay, now E, or the strain is negative 200 kilonewton. E1 is 200 GPa. Let me write in terms of MPa to make easier to calculate. Let me make it longer. So E1 is 200 GPa, 200,000 MPa. So MPa is Newton over millimeter squared, multiply with 2827.43 millimeters squared. Oh, I need to make it to the left. Okay. Take that, okay, and then plus the second one is E2 is 70 GPa, so 70,000 Newton per millimeter squared, multiply with 4071. Okay, now we get all. Okay. Let me just write down the strain here. This is multiply plus
Okay, and then 200. So we get negative 2.3515. This is going to be millimeter per millimeter. But this is the strain, right? What we want to know is how short will be, right? The displacement. Remember the displacement, we need to multiply back the strain with the original length. The original length is 0.5 meter. So multiply with so this will be negative 23515 multiply with 0.5 meter. This is 1.175 meter. Okay. Or maybe negative 117.5 micrometer. Okay. So this is the displacement. And then based on the strain, we can also find the stress. Let me write the stress on the right side. So the stress 1 is strain multiplied with E1, and stress 2 is strain multiplied with E2. So multiply with GPA 200,000 is 47. So negative 47. The negative sign means that it is compressive. Okay. And this one is negative 16.46 MPa. Okay. But negative or positive is actually it's not really big problem. For example, in the free body diagram, okay, if you take the F1 and F2 as the reactions for the P, then this goes to the right. Then when you add this F1 plus F2 is equal P, it's positive. Still okay, but you need to remind yourself that this positive is in the compression. Okay? It's in the compression. So if you want this to be positive, it's okay, but you need to write it's in compression, so you don't forget when you process this. Okay? If not, then you will end up with the elongated pipe. Okay? Like here, it's still okay if you take this into positive P, still okay, but still you need to write the strain is incompressive, which means it's going to be shorter. Like here also, the negative sign means it's compression. But if you work out with the positive one, you get the positive. But you need to write it's a compressive one. But if you work like this, I think it's clear that the negative sign is signs of the compressive on the pipe. So the question is asking this, the displacement, right? Yeah, shortening of this member and then the stress. Okay, that's the one we want to find.
Maybe any questions first? I think not too complicated, right? It's kind of direct questions. What you need to get is the I think this formula here is the stress strain formulation. So I think whenever you see these questions that has E, we can assume that perhaps that will be elastic deformation. Unless that they give you more information. Well, sometimes I think the problem in the textbook I think quite fine, but in another textbook sometimes they give a problem that you need to find out the E by yourself from the maybe on the back of the book. But here I think they give all the information needed, and you can assume based on the information you have, and then that's okay. That's pretty fine.
Okay, now the second one, okay, I think you can check the notes later. Okay, second one we have this. It's quite complicated, but perhaps I will just show you how to deal with this, and maybe I will add additional videos to help you with these questions. So we have three parts.
A, B, C, D. So A, B, B, C, and C, D. And it has some forces applied inside. So it's a tubular segment, the first one. And then solid circular rod segment. So the first one is hollow, it's having a hollow here. This one is solid. And the third one also solid, but different diameter. And the line of action of each of the three applied loads is along the centroidal axis of the member. And this, I think, pretty good assumptions. I think if the questions or if the problem didn't give you this information, I think it's good to assume that all the forces are on the centroid, just to make sure that this is going to be assumed in the uniform material. I think that's the best way to approach this problem. And you need to find the axial stress and the displacement, the nodal displacement is UV, how far it goes, and UC and UD. So if we imagine the forces, all the forces here, although we have forces that is going to the left, that is 13 kilonewton, it's going here, but because of this 18 and 9, we can see that this will go through the right, which means that all these members will be in a tensile. Okay? They will have there will be a tension. So there will be a tension in AD, also in BC, and also in CD. So we could see that it will move to the right with some small displacement that is on UB, UC, and UD.
And I think this is also direct questions. For at least for the first part is direct questions. And don't forget that.
First, let me explain. First one, find the axial stress. I think axial stress based on the equilibrium you can find. The second one, you want to find the displacement, right? But to find the displacement, you need to find how much this member elongated each one. But remember, when you take this elongation, perhaps you need to plus or add some elongation for the displacement. For example, UV. Okay. You see this UV? It's just affected on this first member. So if the first member has E1, then UB is E1. Okay. But how about UC? UC is affected here. This BC and also A, right? Because this is moving like that. So UC is E1 plus E2. Okay? Also UD. E1, E2, E3. Okay? It is going to the right.
So we can start with the free body diagram as usual. We can start from the left or from the right. I think still okay. So maybe start from here, from the left. Okay, so this is 9. This is 18. This is 13. So to have equilibrium, we have this F1 here. So here, F1, or maybe let me write here, sigma F for the X 0. So F1 plus 13 kilonewton is equal 27 kilonewton. So F1 is 14 kilonewton. Okay. Move to the second one. Second one is here. So this is 9 kilonewton. This is 18. And of course we know that from that point of view, this F2 is 27. So F2 is, or maybe right, F2 is 18 plus 9, 27 kilonewton. And lastly, we have the third member. So the third member, we take our, so 9 kilonewton. Here is F3 is 9 kilonewton. And from here we can take the stress. This is F1 over A1, stress 2 F2 over A2, stress 3 F3 over A3. What is the diameter? D1 30, oh this one 30 millimeter and 20 millimeter. And radius means 15. Okay, so I think we can take 14 kilonewton. This is pi. Just to make sure. Okay, multiply with pi. Okay. So it's going to be 35.6650 MPa. This is point, okay, point. Or maybe just 65. F2. F2 is rod segment is 30 millimeter, the diameter, so 15 squared is 38.19. And last one is 28.64. Okay. Okay, and then each member will have all intentions, right? So all have the elongations that is positive. So remember the formula, E is FLAE. So E1, F1, and because we have stress, we can rewrite this. I think we can rewrite in terms of the stress. Okay, so F over A we can exchange to stress L E. So stress 1, L1, E1. The same thing for the other two. So we can write here, this is going to be 35.65 Newton per millimeter squared. L1 is what? 0. Oh, all the L1, L2, L3 are 0.5 meter. Okay, so we can take that. So it's become 500 millimeter, right? Divide 200 GPa is 200,000 MPa, or Newton over millimeter squared. Okay, I think it's nice. So 2565. It's 0.089125 millimeter. And the same thing with the E2, we can take directly. Or maybe just write MPa. I think E also the same, so I think, yeah, I think it's difference in the stress. Okay, and let me write, maybe move this part over about there, and this part there. Okay, and then E3 is the same thing. This will be 0.0716. So we get E1, E2, and E3. Now the statement is to solve the displacement. So displacement UB is equal to E1. Displacement of UC is E1 plus E2. Displacement of UD is E1 plus E2 plus E3. I think you can just adding all those numbers. Okay. You can add by yourself. Okay. For the UB, UC, and UD. Okay. Now, what you need to look at, actually, be careful on this E. Okay. If one of them have different conditions, for example, maybe the condition is not all elongated. Maybe some of them shorted. So please remember that one of them needs to be negative. Okay. And they will be also different in the displacement. So be careful on that. So I think I will finish up until here. So we have 2 questions solved for today's class. I will give you more exercise on chapter 3, and I will give you the result for your quiz. I think tonight I will give you the result, or maybe tomorrow. And since I've seen that perhaps some of you still need statics,
I mean, for general review, what I can do is give you some resources, probably some videos or from other channels, from YouTube videos that I think are very helpful for statics. I think you can also try to look at. Okay, any questions? No? You want to join? Yeah? Okay. Good luck. Good luck finding the job. Okay, so I think I will end until here. So see you next week, right? Next Friday. And happy holiday.